Here's Pocahontas. This is Limits Day 2, the pre-calculus section. The first side here is a review of what we did yesterday, so I was just going to grab a few of these just to refresh. Looking at number 9 right now, this says find the limit as x approaches negative infinity. We got a dominant term in the top. When the dominant term's in the numerator at either of the infinities, the answer is going to be positive or negative infinity. It's up to us to figure out which one. To do that, we have to plug a negative 1,000,000 or a very large negative number into the numerator, square it, recognize that we get a very large positive number, but now we have to stick negative number, negative 1,000,000 for example, into the dominant term in the bottom just to check the sign of that location. If you put a negative 1,000,000 right there, you would have 1 minus a negative 1,000,000, which actually becomes plus 1,000,000, so it's always going to be a positive number down there as you plug in negative numbers. So you'll always have a very large positive divided by a smaller positive, which means our answer will remain positive infinity. If we slide over here to 10, we notice the dominant term, if you find the largest exponent, is right there. And the largest exponent on the denominator means that the denominator is going to get bigger faster than the numerator at either one of the infinities, which means that fraction is getting closer to 0. And let's do one more here. Let's take a look at 12. The dominant term on 12 is located right there in the numerator, which means we're going to have one of the infinities. Put in a very large positive number into the 4x to the 7th, and you still have a positive. Put a very large positive number into the dominant term on the bottom, which is that guy. You'd have a very large positive to the 4th, stays positive, then multiplied by negative 5 would then become negative. So here we would have a positive divided by a negative, which would make it negative infinity. So you should be able to do the rest of those on that side, I hope. But if you turn to the second side, you have a new idea here. Now you'll notice when you're trying to find the dominant term at the infinities, this one has an x squared on the top and an x squared on the bottom. So it has what I like to call matching dominant terms. There isn't one in the numerator or the denominator. They're actually in both locations. So the method that I was taught, and I'll show it to you, and then eventually we won't have to use this, was to do this, was to take the, in this case, 5 things that are in this fraction and divide them all by the variable that is the dominant term, meaning divide each of these 5 things by x squared. And I'll show you why I did that. If you divide everything by x squared, as long as you do it to everything, that's okay. It just changes its looks, it doesn't change its value. 2x squared divided by x squared is just 2. 5 divided by x squared would look like this. X squared divided by x squared is 1. Then you would have 4x divided by x squared, and then 3 over x squared. And in doing so, you have to now hopefully see that the limits as you approach infinity are easily found for the fractions, because this fraction, 5 over x squared, as you stick in 1,000,000, 5 divided by 1,000,000 squared is getting really, really close to 0. The 4x over x squared, you could simplify that if you wanted to, but you don't need to, because if you stick in 1,000,000 right there and 1,000,000 right there, you'd have 4,000,000 divided by 1,000,000 squared. Well, that's getting closer to 0 also. If you put 1,000,000 here, you'd have a 3 divided by 1,000,000 squared, which is getting really, really close to 0. So as the x's get huge, these 3 fractions themselves are getting really, really close to 0, which means all that's left is 2 plus 0 over 1 plus 0 plus 0, or 2 over 1, which is just 2. B has matching dominant terms. The x cubed is your dominant term, so if you were to divide everything by x cubed right now, you would end up with 3 minus 5x over x cubed minus 12 over x cubed then 4 minus 12 over x cubed. If you now do the limit as all the x's become huge negative numbers, you would recognize that this fraction's getting really, really close to 0. This fraction's getting really, really close to 0. And this fraction's getting really, really close to 0. Because fractions that have the denominator getting bigger faster than the numerator are getting close to 0. That's what we did yesterday. So all that's left is that 3 and that 4 with a bunch of zeros, and that is the answer, 3/4. Now I've done 2 examples of the matching dominant terms with this dividing by method because this fraction is supposed to be pretty darn easy. However, I'm thinking that after these 2 examples that some of you have recognized a pattern, and that pattern, which does work, the solution to the limit at the infinities when you have matching dominant terms is the coefficients of those dominant terms. And that does work. And if you recognize that shortcut, we can do some of these fairly quickly. So let's try that shortcut. This one has a little bit of a twist to it though. Watch out for hidden dominant terms. So we got a dominant term of x to the 6th here. I'm on E. A dominant term of negative 3x to the 6th on the bottom. Those are matching dominant terms. So if we apply our little shortcut, we would just have negative 5/3. I wrote 5. Sorry. Negative 5/3. But we've got this extra plus 2 that doesn't go away. So now, if the plus 2 wasn't there, like it wasn't in the first examples we did, then negative 5/3 would have been our answer. But this plus 2 is there, so now we have to figure out negative 5/3 plus 2, which is 6/3. So negative 5/3 plus 6/3 is 1/3. So we used our shortcut for matching dominant terms, and then we had to incorporate this extra up and down shift, which does change your answer. F doesn't have matching dominant terms. That's not the new guy. Let's just talk about this as kind of a refresher from yesterday. If you put in a very large number here, 8 divided by a large number is getting closer to 0. Here's your dominant term on this next fraction, so that fraction's getting closer to 0. So this is just 0 plus 0 plus 3, which is 3. And let's see if we can find another matching dominant term and talk about it. Let's try J. We've got a dominant term there and there. That's our matching dominant term. So we're doing the infinities. It doesn't matter which infinity we're doing, whether it's positive or negative. The shortcut will still give us the coefficients in front of those. Well, that's a 1 and that's a 1. So the shortcut is just going to give us 1 right there. We have to bring this guy down. We can't forget it's there. So the actual answer to this problem is 2. Okay. The other one I wanted to talk about on this side that is new to us is letter N. Letter N, you'll notice, has this 3 to the x power, which for some people is confusing, but I need you to try to visualize this. If you were to stick in a very large number right now, say 1,000,000, to the dominant term in the top, which is that guy, 1,000,000 to the 4th power means 1,000,000 times 1,000,000 times 1,000,000 times 1,000,000, which would give us a 1 with 24 zeros. So I could write that out right now, but I don't want to. Now, put 1,000,000 right there. Well, 3 to the 1,000,000 power is 1,000,000 threes. Now, if you imagine yourself writing all those out and then multiply them all together, hopefully you recognize that is extremely large compared to the 1,000,000 to the 4th power. So this 3 to the x is the dominant term. It's a lot larger than x to the 4th, which means the dominant term for this fraction is in the bottom. We had that yesterday. When the dominant term is in the bottom, that fraction's getting closer to 0. However, we've got this extra minus 4 on there, so now we have 0 minus 4, or negative 4 is the answer. So watch out for that 3 to the x. That might pop up from time to time, and that concludes the matching dominant terms.